AI is easy to underestimate when it is only talking. You ask it to explain a concept, summarize a paragraph, rewrite a note, or sketch a plan. It may be useful, it may be wrong. The blast radius is still mostly inside the answer. Then you connect it to GitHub, a browser, a database, a calendar, a file system, a ticket queue, a cloud account, an internal wiki, a payment tool, a customer record, or a command line. The shape of the thing changes. Now the assistant is no longer only generating language. It is reaching into systems where work happens. People care about MCP, Model Context Protocol, because it sits right at this boundary. The short version is familiar by now. MCP gives AI applications a standard way to connect to external tools and data. But the human version is more important. MCP is a loading dock for capabilities. It can tell an AI app what a server offers. It can help the app discover tools, read resources, and use workflow templates. It can create a shared pattern so apps can connect to outside systems without custom wiring every time. The shared pattern helps builders, but it leaves the governance problem untouched. Once a connection exists, the question shifts from capability to reach. What did we just give it keys to? A tool that reads public documentation is one kind of key. A tool that reads private payroll records is another. A tool that opens a pull request is another. A tool that deletes data, sends email, provisions paid infrastructure, or moves money is another thing entirely. They can all show up in the same tool picker. They can all have friendly names. They can all feel like normal AI features. That is the trap. A normal-looking tool picker can feel like a safety decision even when it is only a connection decision. MCP standardizes connection. Teams still decide whether that connection is wise. So this episode is a field guide, not a hype tour or a panic tour. We are going to take one ordinary case, a failed build in GitHub, and use it to understand what MCP actually connects, where the boundaries sit, how one tool call works, why this is different from APIs, RAG, and agents, and where the safety problems get real. By the end, you should have one practical question for every MCP server you enable. What can this touch, and where does it stop? Start with a boring problem. Someone opens a pull request on your team's web app, and the CI build fails. The developer is tired. The log is long. The failure is probably something ordinary, a type error, a missing environment variable, or a build step that only fails in CI. So they ask an assistant, why did this build fail? If the assistant has no access to the build logs, it can only guess. It can suggest common causes and sound helpful, but it is reasoning from the shape of the problem, not from the evidence. Now connect it to GitHub. Suddenly, the assistant can work from the actual run, the failed job, the logs, the pull request, and the files around the error. It may also have nearby write tools, comments, issues, branches, pull requests, or workflow triggers. For this case, imagine we want the assistant to diagnose the failure without changing the repository yet. That means the first saved job is diagnosis only. Read the pull request, inspect the failed log, search the file named in the error, and recommend the next step. Stop there until the workflow has a stronger checkpoint. Avoid branch changes, public comments, merges, and cleanup actions that remove work someone may still need. That distinction matters. From the assistant's point of view, read logs and open pull request may both be tools. From the team's point of view, they are different kinds of work. Reading a log observes. Opening a pull request changes the collaboration space. Merging changes code. Comments notify people. Deletion can remove something someone still needs. The case is simple on purpose. The starting point is a normal Monday workflow because most AI risk arrives wearing normal clothes. A person wants the assistant to help, the assistant needs context, and the context lives in another system. MCP makes the connection easier, then the team has to decide what kind of help is allowed. That ordinary workflow gives us the whole episode in miniature. What can this connection touch, and where should it stop? The map starts with the host. The host is the AI application where the conversation or agent experience lives. It might be an IDE, a desktop app, a chat app, a coding assistant, or an internal tool your company built. In our case, the host is the place where the developer asks, why did this build fail? The host is in charge of the conversation. It decides what context the model sees, what tools are available, what approval policy applies, and how results get shown back to the user. Then there's the MCP client. You can think of the client as the connection clerk for one server. The host may have several of these clients because it may connect to several servers. One client talks to GitHub. Another might talk to a browser, a database, or a document system. The important idea is the client's role. It is the host connection to a server, and the server is the front desk for a capability set. In the GitHub case, the server sits in front of GitHub features. It may expose tools for repositories, issues, pull requests, actions, security features, or support docs, depending on how it is configured and what credentials are allowed. The server tells the host what it can offer. Resources are context and data the assistant can use, repository files, workflow logs, issue data, and pull request metadata. Tools are functions the assistant can request. In this case, they might read the CI run, search code, inspect pull request data, and later, if the checkpoint is strong enough, create an issue, comment, or draft pull request. Prompts are reusable workflow templates, such as summarize this pull request, triage this issue, or investigate this failing workflow. Resources help the assistant see. Tools help it act. Prompts help structure the work. That gives us 6 plain labels: host, client, server, resources, tools, and prompts. But architecture diagrams can hide the most important part. The server may expose a neat menu. The menu is not the risk model. The risk model depends on reach, credential, approval, logging, and failure behavior. So when someone shows you a clean MCP diagram, mentally add the guard booth. The loading dock explains compatibility. The guard booth explains control. Now follow one tool call. The developer asks, why did this build fail? The host looks at the request and the tools available. It knows there is a GitHub MCP server connected. First, there is a setup phase. The host and server establish what they are, what protocol version they understand, and what capabilities are available. Then the host can discover what the server exposes. In our case, the GitHub server may offer a tool that can list workflow runs. It may offer a tool that can read logs. It may offer repository search. It may offer issue and pull request tools. The exact menu depends on server configuration, account permissions, organization policy, and enabled toolset. The model reasons over the user's request. It sees a structured tool menu so the host can route the request without exposing every GitHub API endpoint to the model. It might choose, list workflow runs for this pull request. The host checks policy. Is this tool allowed? Is it read only? Does it need user confirmation? Does the current credential have access? If the policy allows it, the host sends the request through the MCP client to the GitHub server. The server calls the underlying system, and a result comes back. Maybe the latest run failed in the build job, which gives the model evidence but not enough evidence yet. It chooses another tool, read the failed job logs. The host checks policy again. The server executes the log request, and the assistant can finally see the actual error. Maybe the log says a TypeScript file imports a function that no longer exists. The assistant searches the repo for that function. Now it can answer, the build failed because the pull request imports format duration from usarttime.ss, but that export was removed. The failing file is usart components, SXS. The smallest fix is to import format elapsed instead, or restore the old export if other code still expects it. Notice what happened. The assistant did not become magically trustworthy. It followed evidence, used read-only tools, showed a diagnosis, and stopped before changing the repo. The next step is where the guard booth matters. If the developer says, make the fix, the workflow has moved into a different operation. Now the assistant may need file write access, branch access, test execution, and maybe a way to open a pull request. That should not inherit the same policy as read logs. One tool call may be simple, but a workflow is a chain of tool calls, and the risk lives in the chain. MCP gets confusing because it sits near several other ideas, so separate the layers before comparing them. Start with APIs. An API is the native contract of a system. GitHub has APIs. Databases have query interfaces. Search systems have APIs. Cloud platforms have APIs. And payment systems have APIs. Those APIs are often what the MCP server uses underneath. The underlying service remains the source of the capability. MCP gives AI hosts a common way to discover and call capabilities exposed by a server. If an API is the kitchen equipment, MCP is closer to the service window and menu that an AI host knows how to use. Function calling is the model to host part of the story. A model can produce a structured request that says, in effect, I want to call this function with these arguments. Function calling is useful, but by itself, it does not define a whole ecosystem of external servers: discovery, resources, prompts, transport, and server management. MCP is broader than one function schema inside one model call. RAG is different again. RAG is about finding source material before answering. The assistant asks a question, the system retrieves documents or chunks, and the model answers with that material in context. MCP can connect an assistant to a retrieval system. It can expose search or document resources, but MCP does not prove the retrieval is good. RAG asks, what evidence did the model receive? MCP asks, what external capabilities and context can this AI application access through a standard connection? Those questions overlap, but they are not the same. And then there is the agent, the loop where a system observes, decides, acts, checks the result, and continues. MCP can supply tools and context for that loop, but it is not the loop by itself. You can use MCP in a simple chat, in a coding assistant, or inside a larger agent workflow. The distinction matters because people sometimes talk as if adding MCP means they have added an agent, or as if using an agent means MCP will handle safety. No. MCP is connection infrastructure. The host, policies, credentials, logs, approvals, tests, and user interface still determine what the system is allowed to do. The more agentic the workflow becomes, the more those boundaries matter. The GitHub case is useful because developers can picture it. The same connection pattern shows up outside coding. Think about a licensed news workflow. Reuters has introduced an MCP path for bringing Reuters content into AI workflows, so agents can search, retrieve, and assemble work powered by Reuters material. Reuters gives us a useful example because it separates access from judgment. A newsroom, research team, or media workflow may want an assistant to find relevant Reuters content faster. MCP can help the AI workflow reach the authorized content, but that does not mean the output is automatically editorially sound. The assistant still needs source handling, quote, discipline, rights boundaries, freshness checks, human review, and a clear difference between retrieved material and generated interpretation. Authorized access is not the same as finished judgment. Now take Playwright. In VS Code documentation, Playwright MCP appears as an example server that lets an agent interact with web pages through a browser. For a working developer, that browser access can be incredibly practical. The assistant can open a page, click through a flow, decline a cookie banner, inspect state, capture screenshots, and help verify that a web app behaves correctly. For front-end work, that is not a toy. The assistant no longer has to guess from a description. It can inspect the page state directly. A browser is also a messy boundary because it loads untrusted pages full of text, and text can contain instructions. Some of those instructions may be malicious, manipulative, or simply irrelevant. If the assistant can only look, the risk is smaller. If the assistant can look, click, copy, paste, submit forms, read cookies, access internal pages, or combine browser data with another tool, the risk grows. The phrase connection becomes permission is the wrong mental shortcut. The connection is only the route, while permission is the governed ability to use that route for a specific job. Reuters and Playwright are almost opposites. One is trusted licensed information, and the other is a browser pointed at a living web page. Both are useful. Both still need boundaries. With Reuters, the question is, what content can the assistant retrieve, and what review protects the final output? With Playwright, the question is, what page can the assistant touch? What actions can it take? And how do we prevent untrusted page content from steering the rest of the system? Different servers, same field guide rule. Label the reach before you trust the workflow. The strongest failure mode is connection becoming permission. A team connects a server, the tool menu appears, the assistant can see it, and everyone quietly starts treating the menu as a safe set of things the assistant is allowed to do. The tool menu alone is too shallow because tool menus flatten consequences. In a clean interface, read weather, read payroll, open pull request, send customer email, delete record, and provision server can all look like neighboring buttons. Those are not neighboring decisions, so the system has to preserve the difference. Start with the flat tool menu problem. If every capability appears as a tool with a name and a short description, the model may not understand the human consequence of choosing the wrong one. Even the human may stop seeing the consequence if the interface treats everything as routine. Then, there is capability laundering. Capability laundering happens when a risky action passes through a safe-looking chain. A tool may look harmless by itself, but when combined with another tool, it becomes more powerful. Read from private docs, summarize into a message, and send the message externally. Each step can seem normal while the chain still leaks information. Or, read a web page, follow hidden instructions on the page, use an internal tool, and post a result somewhere else. The danger may not live in one tool, it may live in the path between tools. Local servers add another wrinkle. A local MCP server may run near files, shell commands, browsers, or credentials on a user's machine. A local server can be powerful for individual productivity, and it also raises concrete setup questions. Who installed it? Which files can it see? Which commands can it run? And where are credentials stored? Remote servers have their own version of the problem. They may expose organization data over the network. They may depend on OAuth scopes, tenant policies, token audience validation, rate limits, logs, and admin review. Whether the server is local or remote, does it work, is only the first check. The better check is, what does this server let the assistant reach, and what other tools can be chained with it? Official or trusted connectors still need policy. A server can be legitimate, the publisher can be real, the protocol can be followed, and the credential can be valid while the workflow is still over-permissioned. A real workflow earns trust at the composition level: server, credential, toolchain, approval, log, and recovery path all working together. Use a decision frame. For this episode, the frame is port purpose, operations, reach, and trust and trace. Purpose is the job. What specific workflow are we improving? Not connect the assistant to GitHub, which is too broad to govern cleanly. Say, let the assistant diagnose failed CI runs on pull requests. Or, let the assistant retrieve licensed news material for an editor's research packet. Or, let the assistant use a browser to verify a checkout flow and staging. The narrower the purpose, the easier the rest becomes. Then operations define the kind of actions allowed. Reading a log, opening a branch are not the same kind of action. Use a risk ring: observe, reversible, external, and irreversible. Observe means the assistant can look. Reversible means it can create or change something that can be reviewed or undone. Irreversible means damage is hard to unwind. Reach is the blast radius: which account, repository, folder, database, tenant, record, browser session, or payment instrument can this touch? For failed build diagnosis, reach asks whether the assistant sees one repo or every repo, whether it can see secrets or private issues, whether it can reach production branches, and whether it acts as the user, an app, or a service account. Reach turns vague safety talk into a map. Trust and trace is the operating layer: who publishes the server, who owns it internally, which credential it uses, which approval screen appears, what gets logged, who reviews the logs, and how to revoke or disable the connection. Port is plain enough for setup and incident review. Here is the boring workflow I would actually use. Pick one official or clearly trusted server and one boring read-only job. For our GitHub case, diagnose failed, CI runs on one repository. Not, give the assistant GitHub. One repository, one job, read only first. Use a narrow credential. Do not start with a personal token that can touch everything the developer can touch. Use the smallest credential model your environment supports. Review OAuth scopes. Apply organization policy where it exists. Limit local tool sets where configuration allows it, and enable only the tools needed for the job. For the first pass, the assistant may need to list runs, read workflow logs, read pull request metadata, and search repository files. Leave merge, delete, publish, invite, payment, and admin powers out of the first version. Turn on logging. What tool, what inputs, what target? Then run the 10-prompt failure test. Ask normal questions, ambiguous questions, and request for a fix. Ask it to post a comment, merge, read something outside the repo, use a secret, follow instructions from an issue comment that says to ignore policy, combine the GitHub tool with a browser or messaging tool, and explain what it cannot do. The test has two parts. The assistant should get the right answer, and the system should refuse the wrong action in the right way. Only after that should you add one reversible right. Maybe it can create a draft issue. Maybe it can open a pull request against a branch, but not merge it. Maybe it can prepare a comment, but a human sends it. When you add the right, add the checkpoint. The screen should name the action, the target system, the supporting facts, the undo path, the people notified, and the human choices: approve, revise, cancel, or escalate. At that point, human in the loop becomes a real screen with enough information to make a decision, not a slogan. The Monday artifact is one page, an MCP inventory, not a strategy deck or a grand governance program. The columns are server, owner, local, or remote, tool, risk ring, data reached, credential scope, approval rule, log location, and kill switch. Fill it out for every MCP server and every important tool. For GitHub, the row should show who owns the server, who operates it, which tools are enabled, which data they reach, which credential they use, where approval happens, where the logs live, and how to turn the connection off. Any blank cell is unfinished architecture, and that strictness is useful because blank cells are where incidents hide. Most teams do not fail because they cannot understand MCP. They fail because the connection felt normal before the boundaries were written down. The inventory makes the invisible part visible. It also gives every team a more useful conversation. Security can point to a row and say, this server has right tools enabled, reaches production repos, uses a broad credential, has no approval rule, and has no known log location. Product can turn a broad feature request into a buildable one. We want read-only CI diagnosis for one repo, with a path to draft pull request later. The request becomes specific enough to build. Engineering gets a maintenance standard. Here are the valves, labels, meters, and shutoffs. Here is who owns them. Mature plumbing has valves, labels, meters, shutoffs, and an owner. MCP is useful infrastructure. AI systems become much more helpful when they can reach the context and tools that work actually depends on. A coding assistant is better when it can read the failed build log. A research assistant is better when it can retrieve authorized source material. A front-end assistant is better when it can open a page and see what the user sees. An internal assistant is better when it can work with the systems people already use. The good version still needs a map, connection, tool menu, server publisher, credential, and human approval. Each answer different questions. A human approval button is only useful when the human can see what they are approving. So when someone says, we added MCP, do not stop at the acronym. Ask for the job, the allowed operations, the reach, the trust chain, the trace, and the stop switch. For the failed GitHub build, the safe first step is simple. Let the assistant read the pull request and logs. Let it diagnose from evidence. Make it stop before changing the repo. Then, if that works, add one reversible write behind a real checkpoint. These standard marrow, the failure paths tested, and reversible writes behind a working checkpoint. The field guide matters because easier connections need name purpose, bounded operations, visible reach, traceable trust, and a stop switch. Open the loading dock. Staff the guard booth. Write down what the key can touch before you hand it over. If this helped untangle the system, hit like, subscribe, and follow Archive of Worlds for more field guides to the systems shaping work, money, tech, and everyday life. Keep the system human.